Alright, hello everyone. So I answered question 43 from chapter 20. So first I'll read the question for you. An ion with a charge 1.6 times 10 to the negative 19th coulombs moves at speed 1 times 10 to the 6th meters per second into and perpendicular to the 0.3 Tesla magnetic field of a mass spectrometer. After entering the field, the ion moves in a circular path of radius 0.31 meters. What physical quantities describing the field and the ion can you determine using this information? Determine them. So we're looking for physical quantities describing the field and the ion, and we'll start out with what we already know. So we know that the charge of the ion is 1.6 times 10 to the negative 19th coulombs. We know the velocity is 1 times 10 to the 6th meters per second. The strength of the magnetic field is 0.3 Tesla, and the radius is 0.31 meters. And then I just have a drawing over here to kind of show you guys what it looks like. If you're wondering, that's exactly what a mass spectrometer looks like. But as you can see, as the ion moves into the mass spec, once it hits the magnetic field, it goes in a circular motion, and then you can see the radius there. And so I decided that a physical quantity I would be able to find was the mass of the ion. So I took two equations, which are right here. F equals QVB and F equals mv squared over r. And I combined and rearranged them so that I could solve for the mass, which is what is shown here. So the new equation is m equals QBr over v. And in this equation, m is mass, q is the charge of the ion, b is the magnetic field, r is the radius, and v is the velocity. So then I just plugged in all of my known numbers that I had up here into the equation, and then I just plugged them in and solved, like I just did the math. And I found that the mass was 1.488 times 10 to the negative 24th kilograms. And so once I rounded, it was 1.5 times 10 to the negative 24th kilograms. And I think that this answer seems both logical and reasonable.